So, some tips back to chapter 5. It's been a hot minute since we have done 5 here. So, of course, factor it. When we least expect it in chapter 5, you can factor greatest common factor out. Then you might have an identity. Fractions, I'm making those common denominators. If I'm stuck, I'm going to write everything in sine and cosine, of course. And if I have to figure out where to draw a triangle, I'm going to be using that. All students need calculus. Also, it's important to be watching our calculator mode, especially when I get into chapter 6. I'm going to try to do 5 and 6 today. When you get to 6, of course, our calculator modes need to be in degrees. And I've got my calculator up and ready. I'm going to double check it too. Now, you can see this lavender packet. You know, I get carried away. You will be provided the identity sheets that are in there on the final also. I put them in the packet so you have them to use not only for these problems we're going to do here together, but also for your final exam questions. All right, let's do it. So let's practice. Verify the following. So of course I'm going to work on the left side, the more complicated side, and I'm going to try to simplify it down to the right side. So first thing that jumps out to me, I can factor. You have a cotan in both terms. So I'm going to factor a GCF, a cotan out. So that leaves me with secant squared and 1 to hold the place. Now, as soon as I saw that secant squared, I was like, identities. Squared, of course, we're going to look under Pythagorean. Secant squared minus 1. There it is. So I'm going to replace that with tangent squared. Scroll back. You need taller shoes. All right. So, and I think we're pretty darn close. That's why I don't need a lot of room. I'm not too worried about it. Now I'm trying to simplify that left-hand side down to tangent, which I can do, because of course cotan is 1 over tan. And then I'm just going to reduce some tangents out, and we got it. I'm going to take a tangent out, I'm going to knock one out of here, and I made the tangent. So factoring is, of course, our very best friend. No shotgun to it, clearly says to factor. So I'm going to factor. Once again, we have a GCF, a sine squared. So I'm going to have my cosine squared and a minus 1 to hold the place. Now again, I see that cos squared and 1. I'm going right to my identity sheet, Pythagoras. But we do have a little glitch here. I have on our expression cosine squared minus 1. I'm looking at this. The signs are switched. Because remember, I have positive cosine squared and I have negative 1. So I can still use this. I'm not going to put sine squared though. I'm going to change the signs. I'm going to make it negative sine squared. So now that would match up to the expression I have. So I'm going to go back, put negative sine squared, and do a little simplifying. Okay, well, sine squared, I'm going to combine it to sine to the 4th, and I'm just going to throw the negative out front. Got it. All right, everybody's favorite, fractions. Whenever we add fractions, you need a common denominator, so I'm going to make the bottoms match. So I see the right has a 1 plus sign, so I'm going to sneak in a 1 plus sign over here so they match. We're going to write small. The left denominator has cos, so I'm going to put a cos on this one. Okay, we're going to multiply before we add. Now to multiply those first two numerators, not going to lie, kind of sucks, because we're going to FOIL it all the way out. I got to do 1 and 1, 1 sign, another sign. I'm just going to combine it. And then sine, sine squared. I should have wrote a longer fraction bar. Now, the bottom, I don't care if you distribute the bottoms or not. We just care that those match. So, it's Friday. If we're tired, I'm just going to leave it 1 plus sine times cos. Okay, cos and cos, got it. Denominator, just going to leave it. We just care that they match. Now, the reason we do all of this is so you can add any like terms on the top. But I'm like, out of the 4 terms on the top, none of them are like. I'm like, oh man, but I didn't do this all for nothing. Sine squared plus cosine squared is on our identity sheet. Hopefully we remember that one. What's sine squared plus cosine squared? 1. So I'm going to put this front one and this one together. I'm going to combine those as 2. So I'm going to write the top. I'm going to move up here is 2 plus 2 sine x. And I still have my common denominator. Now I still think I can simplify. Hello, Josue.
You didn't say practice quiz paper review?
I can't get it right now. Sorry, my friend.
Okay.
All right, I'm going to factor a 2 out of the top. I should have called this. I'm going to leave the bottom. All right, now what can we cancel? You got it. Now, can we write 2 over cosine any simpler? I see you guys saying it. Because think about this. When we cancel these, this is really a 1. So what's 1 over cosine? Secant, secant. It's on your sheet, secant. So I'm going to write my final answer is 2 secant. That's a C, a sloppy C. All right. Any questions about that stuff? Yeah, it seems like another lifetime ago we did these. Are you loving it? Loving it? Okay, let me scroll it a little bit. Okay, solving. So of course I need the answers 0 to 2 pi. So in radians. I mean, that's not a big deal. Now, of course, I'm going to get x alone. I'm going to add the 1 over. Let's go ahead and divide the 4 off too. So I'm going to add 1, divide by 4. That's not a big deal. How are you getting rid of the squaring? Square root. Okay, now I'm like, oh boy. So I need my plus or minus since we're square rooting. Love it. Square root of 1, got it. Square root of 4, crushed it. Now the plus or minus, I'm like, oh dear God. The plus or minus, remember, is we are in all 4 quadrants. Because sine's positive in 2 quadrants, it's negative in 2 quadrants. I'm not even going to write down the all students take calculus. I just know I'm on all 4, so let's just get to it. I'm going to start in 1. Now, sine, of course, you have opposite hypotenuse. Opposite hypotenuse. For the love of math, what's the missing side? Square root of 3. And more importantly, what special triangle are you on? A 30, 60, 90, or 45, 45, 90? 30, 60, 90. And what angle is across from 1? The 30. So there's my very first answer. Now, I will put that in radians, comma. I will put those all in radians in a hot minute, but let's just get our angles. Now, you got the 30, that's the key. I'm not going to relabel all the sides. We care about the 30. Now, I'm going to measure from 0 over. You are 30 short of the 180 line. So my second one would be 150. 180 minus 30. Quadrant 3. Again, I'm not going to relabel. I care about the 30. I'm going to measure from 0 to 180, 30 more. And then I'm going to get the last one in quadrant 4. Of course, 30. 0 clear around. You're 30 shy of a full circle, a 360. So 330. Okay, do you remember what to multiply by to convert to radians? Pi over 180. Okay, all right. So I'm going to list all the final answers, the radian answers. I'm going to sneak them in, I guess. Pi over 6 is 30. 5 pi over 6 is the 150. 7 pi over 6 is the 210. And 11 pi over 6 is the 330. Good stuff. It's all coming back to you, right? The looks on your faces right now is priceless. All right, I'm going to solve this one. I'm going to subtract the square root of 2 off. So negative root 2. And then I'm going to divide by 2. So we're going to have, and some of you could have done this all in one step, I'm well aware. Now, as soon as I see square root of 2, what special triangle are we on?
45.
Got it, 45. 45, 45, 90. We just have to figure out where to draw it. It's not plus or minus, so thank God it's not in all 4. I'm not going to have 4 answers. That makes me super happy. I'm using my all students take calculus. And remember that tells you where everything's positive. Everything's positive in 1. Sine's positive in 2. Tan in 3, cos in 4. Well, I see we have negative, so that gets rid of the A and the C, because cosine would be positive in those 2. So I'm going to draw over here 2 and 4. And you guys already told me 45, 45, 90. I'm not even going to bother labeling the sides. We're after the angles. I'm going to measure from 0 over. You're 45 short of the 180 line, which would be 135. And then we're 45 past the 180 line. So 180 plus 45, 225. All right, and then the radians versions, 3 pi over 4, 5 pi over 4. Yeah. All right, one more solving. I know I'm getting carried away on the solving, just because it's been a while since we've done it. So let's do this guy. So I'm going to add the 2 square roots of 3, and we're going to divide off the 4. And I'm going to reduce the 2 over 4. Okay. So that's not looking so bad, okay. So of course what we're going to do is kind of similar. I'm doing the all students take calculus. We just have positive root 3 over 2. So we're only in 2 quadrants. We won't be in all 4 happy about it. So cos, of course, positive in 1 and 4. All right. Now I'm going to label the sides cosine. Adjacent, hypotenuse, 1 for the love of math. You told me earlier, 30. So there's my first answer, 30 degrees, pi over 6. Second answer, of course, 30. Okay, and of course I'm going to measure clear around. We're 30 short of a full circle, so 360 minus 30, of course, 330, which is 11 pi over 6. Okay. All right, any questions on those I can answer? And like I said, I'm going to do this whole lavender packet with you, but just like your notes packet, I'll have you turn that in too and give you points for having everything filled in, of course, okay? All right, let's do chapter 5. So now I'm going to have to go to the identity sheet because we're going to use that sum and difference identities that we have not used in a hot minute here. Find the exact value of these. Now, notice they give you some important information. Both of these guys are in quadrant 4. Okay, well, let's start with you. I'm just going to, on the side, draw the triangles. So I'm in quadrant 4. You. So, of course, they give you the sides. We have opposite, hypotenuse. Do we know the missing side just off the top of our head without Pythagorean theorem?
15.
15. 8, 15, 17. It's a triple. Got it. Now, I also need V. So I'm just going to set it up. That's in quadrant 4 too. And they tell you cos of that is adjacent hypotenuse. That's an easy one. What's the missing side? 3. Now, due to the location, does the 3 need a negative? Yeah, because you're going down. Obviously, it looks like a dot, not a negative. Obviously, the 15, because you're going right, does not need a negative, so don't worry about it. Now, to actually get sine of u minus v, I got to scroll to the identity sheet. So that is that sign, here it is on the back, of a difference. So I'm using this identity here, but I'm going to swap out the a and b's with u and v's. So I see you guys writing, so I'm going to leave it up there a minute because I see you're writing it down. I'm going to write it down too, but just so you don't have to flip back and forth, because I'm so nice to you. In every, like if you're working ahead at all, which is fine in the review packet, any formula sheet I've given you in that lavender packet, you will get on the final exam too, okay? All right, so I'm gonna scroll back up and let's write down this formula. So I'm gonna have sine u cos v, you already got it written down. And then we have minus cos u sine v. And remember, sine u, cos v, all of that stuff is fractions. You're comparing two sides of your triangle. I'm going to have 4 fractions in this expression. Sine of u. Well, they already gave you that one. I mean, you could look at the picture, but they gave me that one. Cos of v. They also gave me that fraction, but you can look at the picture. Okay, cos of u. I mean, I got to look at the picture of that one. Cos of u. Adjacent hypotenuse, so 15 over 17. And then sine of v, I gotta look at the picture for that one. Opposite hypotenuse. And you can punch all that in your calculator, do it by hand, whatever you want to do. You end up with 13 over 85. All right, so let's do another one kind of similar. Read close because you're in different quadrants this time. So u is in quadrant 1. Let's draw u first. All right, sine of u 4/5. So opposite hypotenuse, or course, that's gonna be 3. Quadrant 1, everything's positive. All right, and I gotta draw V. V is in 3, it says. I'm kind of just drawing a big quadrant 3 over here. And it tells me cosine, so adjacent hypotenuse. That, my friends, is also a triple. Do you know the missing side? 7, 24, 25. Good work, Morgan. Your geometry teacher would be proud. Check it. Does 24 need a negative due to where it's located on the graph? Yes, it sure does, because you're going down. Okay, so we're ready. So again, we already wrote down the identity on the previous one. It's still sine of the difference, so I'm just going to go straight to the fractions. So sine u cos v. Well, they gave you sine of u. They gave us cos of v minus. So cos u, here, look at the picture. Cosine of adjacent hypotenuse, so 3/5 sine of v. Here, look at the picture, opposite hypotenuse. Okay, I punched that all in. I did it earlier. You end up with 44 over 125. I'm hoping this is starting to seem a little familiar to us. It has been a while since we've done this. All right, double angle identity. Okay, so obviously I'm gonna have to scroll to the identity sheet, which I'm gonna do in a minute. But let's look at this information. Cotangent of x is 2/3, sine x is greater than 0. I gotta figure out where to draw this though, because I didn't straight up tell you. Let's try to figure that out. So all students take calculus. Okay. So I like, of course, that sine of x is greater than 0. That means, of course, sine's positive. So that gives me 2 potential quadrants. Sine's positive. Okay. Now, the other thing they give you is cotan. Well, we're used to working in sine, cos, tan. So I know tan would just be the reciprocal. P there, positive. Well, I know tan's positive in those two. Well, clearly, where are they both positive? Where did I circle purple and blue? Quadrant what? 1. Okay, and I'm going to label our sides accordingly. So opposite, adjacent. Now, I have a pretty good feeling I'm going to need the hypotenuse when I get to it. This is not a special triangle. How are you going to find the hypotenuse? Old school what? Pythagorean theorem. Which some of you can probably even do in your head. Because what's 2 squared? 3 squared. So 4 plus 9. So I'm going to have the square root of 13 off your Pythagorean theorem. Now, we're doing cos of a double angle. Okay, I'm going to go to the identity sheet. Cos of a double angle on the back. Okay, right here. Now, you have 3 of them. It doesn't matter which one you use. I'm just going to use the top one because I don't know, I feel like doing the top one. So I'm going to jot down cos squared minus sine squared. So I'm going to do cos squared minus sine squared. So that's right off the sheet, okay? I'm going to plug the fractions in. Well, cosine adjacent hypotenuse. At first I was like, oh gosh, I probably should rationalize. I'm going to think about that in a minute. Then I'm going to do sine, opposite hypotenuse. Now, I know those fractions aren't rationalized, but you know what? I'm not going to rationalize them. Because what happens when you square a square root? Cancel. So I'm not even going to get in a twist about it. I'm just going to start squaring. 2 squared 4, square root of 13 squared. 3 squared 9, square root of 13 squared. Easy peasy, negative 5/13. Got it. Why rationalize? All right, let's do 11. Write the expression sine, cos, or tan of an angle. We're going to have to look at the identity sheet for sure. So what jumps out to me, of course, right away, cos, cos, sine, sine. So I'm going to scroll to the sheet. I'm looking for cos, cos minus sine, sine. Cos, cos. Oh. So we have cosine of a sum. All right, well, I can add 2 angles together. I can do it. I can do it. I can do it. I'm going to add the 2 angles together. What's 60 plus 20? 80. So cos of 80, done. Now, I'm going to do the same thing for 12. I'm pretty confident 12 is a tangent, right, with all the tangents in there. So I'm looking for minus on top, plus on the bottom. Let me scroll to it. Minus, I went too far. Minus on top, plus on the bottom. So we have tangent of a difference, tan of a diff, okay? So you might need your calculator to figure out this. What's 325 minus 86? 239. Got it. Any questions on that? Okay, we got one last problem from chapter 5, and then 6 is short. 6 was a really short chapter, so I thought we'd do those 2 today, and then we'll tackle some more on Monday. Okay, loading dock ramp, I'm going to throw some pictures here, is 20 feet long, rises at an angle of 23 from the horizontal. Let's start with that. So horizontal, of course, straight across, the right triangle, and it says angle of 23 degrees. Now I'm thinking about, my ramp. I'm thinking about like a skateboard ramp or something. Your ramp is the hypotenuse. It's the slanted piece. So that's your 20 feet long. Okay. I'm going to keep on reading. Due to a new design, a longer ramp's to be used, and the angle's reduced to 7. Okay, all right. So I'm going to start drawing this. Now angle 7 is a really tiny angle, not drawn to scale. Let's just say that, right? Now, I don't know how long the hypotenuse is. I don't know how long the ramp is. It says it's going to be longer. Okay, what else? But this is kind of clutch. It says that it reaches 6 feet up the wall. Well, your wall, remember, is always your height or your altitude. Now, the question is, what in God's great earth are we trying to actually find here? Okay. How much farther out from the dock will that put the foot of the ramp? So how far from the dock, the foot of the ramp? So I want to know what's the distance between these, from the wall to the bottom of the ramp. So I want to know that over here, from the wall to the bottom of the ramp. So I'm going to have to solve both of those triangles. We're going to have to do them both. And then we're going to compare what the difference is. Well, for this one, okay, I have adjacent that I need to find out, and I know hypotenuse. Adjacent hypotenuse, I'm going to do cosine on it. So I'm going to do cos of 23 adjacent over hypotenuse. Now this is one you'd want to make sure your calculator mode is in degrees. Okay, I know you times 20, you can do it. So 20 cos 23, I punched it in earlier, you get 18.4. Okay, now I'm going to do the purple triangle. I'm going to solve this one. But sides, I have opposite adjacent. So I'm going to switch it to tan. So opposite over adjacent. All right, this time a little more work solving. I'm going to multiply by x, get rid of the bottom, of course. And then I know you would divide tan of 7 off, which I did earlier. You get 48.9. So the final answer is this. Here's what we're trying to answer. How much further out from the dock will that put it? So if the original one's at 18.4, the new one is 48.9. How much further out is that? How are you going to find that? You just have to what? Subtract them. So subtract the 2. You can subtract it. Your final answer, 30.5. No, wait. That's kind of easy. All right. Let's look at 6. 6 isn't super long. Inspirational quote time. The future belongs to those who believe in the beauty of their dreams. Eleanor Roosevelt. Okay. Obviously, you're going to get, let's look at the formulas. You're going to get the formula sheet. So these are the different formulas you're going to have. Law of signs, I don't even know if you really need that one. But remember the angle across from the opposite side. All of your law of cosines. Remember lowercase letters or sides, capital letters or angles. And then we have those area formulas. So this is the exact identity sheet that you will be getting. All right, solve the following triangles. Now I like this first one because I'm like, ooh, okay. So I see an angle C, side C. I can do law of sines. Law of sines is always easier. So I'm going to do sine of 65 over side C because we don't know these are right triangles. So SOHCAHTOA is out right now. If you're like, oh, I'm going to use SOHCAHTOA. No, you don't know. Okay. Only other thing we have is side A. Remember, side's on the bottom. So I'm going to find the angle across from it, which would be angle A. Okay, little calculator time here. We're going to multiply these together. Multiply on the diagonal. I'm going to do my other diagonal, 12 sine A. And then really I'm going to go to the calculator from here. So I'm going to pull up my calculator. I'm going to punch this one in. I'm going to make sure I'm in degrees. I'm going to, of course, first just hit the 6 sine 65. 6 sine 65. Okay, I'm going to divide off the 12. We're just going to do it. Maybe, come on. Okay, do you remember what you're going to press in your calculator to get the angle, though? Good. Second sine, sine inverse, sine to the -1. Second sine. I'm too lazy to type in that decimal, so I'm going to cut and paste it in, second negative key. You know, let's just make it easy. Let's round to 27. I'm going to say 27 degrees for it. Now, solve the triangle. That means I need all angles, all sides. Okay, well, I've got 2 out of the 3 angles. I think I can get the third one pretty easy. Because all 3 angles always add up to what? 180. So I did 180 minus 65 minus 27. Notice I don't have any work for that. What is the one thing I'm missing?
Side B.
Side B. So really what I'm going to do is I'm going to kind of set up the same original fraction. So I'm going to start sine 65 over 12. I've got my sine of 88, angle B over little b. You can do the cross products and solve it. You guys are great at that. That was never a problem. You get 13.2. Got it. All right. I don't love number 2 because I gave you all sides. Can you use lost signs? No, you don't have an angle on opposite side. Oh, God. Okay. So we're going to use law cosines. Now, when you have all 3 sides, too, it's important to remember, let's look at our law cosines here, because you're like, which one are we using? It's important to remember to make sure your triangle C is in proportion. Across from the biggest side, the biggest angle. Smallest side, the smallest angle. You want to start with the biggest side. So, I see my biggest side is 20, so I'm going to use this third one, the C squared equation. I just happen to know it. So I'm going to do 20 squared, I'm using the third one, A squared plus B squared minus 2AB cos of angle C. And we're going to solve for that angle C. Now, 20 squared, I know it. Okay, now remember, we cannot punch in all these numbers in one fell swoop on this side. They're not all like terms. This at the end has cos of C, these do not. So I did punch these in my calculator. I just did 12 squared plus 16 squared, that's 400. And then I did 2, 12, 16, I multiplied that together. Now I'm trying to get that cos of C alone. I get rid of the 400 next. You're going to subtract off 400. Don't let it scare you. If I subtract 400 off, what do you have? 0, which is okay. 0 is just a number. Nobody panic. I'm going to divide off the negative 384, which again is still 0. We're not going to panic. That's okay. All right, hit it on your calculator. Do second cos of 0. You'll get an angle. Got it. Okay. Should have wrote smaller. So next, we only have a couple things left to find here, of course. I've got all the sides. I got 1 out of the 3 angles, so I'm going to find the rest. But now I can go to law sines. So I can do sine of 90 over its opposite side. And remember, I'm working biggest to smallest to keep it proportional. So I am going to go to B next. I'm going to do the 16 and sine of B on the top. Blah, 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 cross products. I'm just going to give it to you, you get 53. Short, sweet, how would you find A? They all add up to what? 180. So 180 minus 90 minus 53, you get 37. All right. How about this? Let's do, these 2 area ones are super easy. And I feel like we're losing enthusiasm a little bit. Should we save the word problem for Monday to kick off Monday with it? All right, the area ones are super easy. That's why I said let's do those. So you've got the formulas. So I see, of course, number 4, I have 3 sides. So that's that Huron's area formula. The other one, I've got two sides and an angle, so that's the formula I'm gonna use for this one. So super easy to get your area. It's 1/2 times the sides times the sine of your angle. And I mean, there's no magic to it. I just punched that all in my calculator, you know? And I got 1,675.2. And the geometry teacher makes me want to label that. Okay, Huron's area formula. So first thing I'm going to calculate is this guy. I need the S, the semi-perimeter. You just add all three sides, divide by 2. So I just did, in my calculator, 17 plus 23 plus 31 over 2. And I punched that in, and I got 35.5. Now I'm ready really to go to my area formula. So your area formula is S, and then it's S minus the first side, S minus the second side. I'm running out of room, I already know it. Minus 23, that's a minus 23. I'm off the edge already. And then I'm just gonna throw it down here, S minus the third one, because clearly I've totally ran out of room. All right, punch that in. Really, I don't know if I'd write it, I would have just punched that in. You get 192.2. Okay. Do we want to tackle the word problem or save it? Let's save it. Let's save it so it's fresh in your mind on Monday. We will kick it off.